Hello, 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 as well. Third and last epi of the night, or the day, or whatever. Okay, probably keep this one short, just like I kept the writing short, because I'm starting to get tired. It's 4:20 a.m. All right, second episode of hacking is Thursday, January 7th, 2025. So I want to start this new series where I'm hacking for fun and for trying to push relational programming further. I am still just trying to think through what might be interesting. I think it's worth thinking about a little bit. I came up with some organization yesterday that I don't know how helpful it is, but it got me started. I had the fun and interesting and useful techniques and the rate limiting blockers for relational programming. Yeah, I'm not sure. I think useful techniques is not exactly the same as fun. So maybe I'll break fun up. But something like self-reps seems interesting because I think that's both fun and might have some useful techniques. So when Nada and I were playing around with self-reps, that actually I came up with a trick to try to to play with the reproducing programs, which are kind of like quines, which I'll just show you real quick, actually. So I guess we will do a little hacking. Stop it. Let's go to faster miniKanren. All right, so I just loaded the quines interpreter. Okay, there we go. There's our nice little quine. And let's grab the expression. Let's update the variable names. Okay, there we go. Easier to read. So that is like the canonical Lisp or scheme quine. Okay. And of course, we can not just do quines, but we can do twines. So twin quines, which are P and Q. So P evaluates the Q, and Q evaluates the P. Now, this is true of any quine. Actually, all quines are twin quines. Well, let's see. Is this actually the same? May just be the regular quine. List. No. It's actually a little bit different. Well, anyway. In any case, it should be the case that our regular vanilla quine is also a twine. Let's check that out. Yeah, so I guess we are hacking now, huh? Just playing around. Let's just take our canonical quine. All right, let's say P is our canonical quine. Notice I better put that quote in front. All right. Yeah. Yep, that works. So our regular quine is a twine, so every quine should also be a twine. Okay, so we want to get non-trivial twines, which are different, where P and Q differ. So the way we've done this in the past is we use the disquality constraint on P and Q, and we say that those have to be distinct terms. They have to be different terms. And looks like they are different, although I think they only differ from the quote. Let me grab one. Okay, this expression has a quote on it. This one doesn't. I think that's literally the only way they differ. Let's just try it. Let's test that. So we can take the two expressions, and I will add a single quote to each one, because we have to evaluate these in scheme, or they will be evaluated in scheme when we feed them to equal question mark. Okay, so these obviously won't be the same. False. But if I remove the extra quote here, then they are the same. Yeah, so they only differ from a single quote. All right, so they are different. Those twines, they are twines that are in some sense non-trivial in that they're not identical. However, they're almost identical. They just differ from a quote. When Nada and I were playing around with the self-reps, I was running into this problem yet again. In fact, in a paper review, one of the reviewers of the paper is like, yeah, these are not very interesting. I was like, yeah, this is kind of right. But I thought, oh, well, what if we use something stronger than disequality? Because what we could use is absento. So absento, like disequality, takes two terms. And it says that the first term does not appear within the second term. Okay, so and also P and Q can't be the same. So it's like saying P is not equal to Q, and also Q doesn't contain P. Like, so Q might be a list of five terms, and none of those can be P or can contain P. Okay, so that's what absento is. And to do this right, we have to do it both ways. Okay, so the idea is to try to get something that's structurally different, because in the first example where we saw where the terms only differ in terms of a quote, the absento constraints would be violated because you have quote something, quote some term T, I'll call it quote of T and T. Well, T obviously appears within quote of T, so you'd violate the absento constraint. So we end up instead getting things that are structurally a little more different. So here we have a call to list on the outside, okay? And then when we run it, we have a procedure application where we have a lambda on the outside. So it's an application, direct application of a lambda, so that's like a let. That'd be equivalent to a let. So you can think of it as a let versus a call to list, that type of thing. So those are different. We still have two quotes versus let's see, go back to the original. So here we have this lambda expression has 3 quotes. This one has 2. I think those are the same lambda. It looks like it. Yeah. So we still have this game where, within this overall list, within this overall term, there's a subterm, that's almost exactly the same as this other subterm. They only differ in terms of a quote. So that's kind of interesting. And then this subterm also, is appearing here. I don't know that you can easily build these sorts of structures without some sort of shared or duplicate structure. I don't know, maybe there are ways. But anyway, this is a little trick. I wonder if this suggests a new type of operator, because if we had thrines, okay, so you can also have thrines, which are PQ, and R, right? And here it's kind of like, a cycle around the world. Q goes to R, and R goes to P. Okay, so now we have to do all these. P doesn't appear in Q. P doesn't appear in R. Q doesn't appear in R. Actually, I think P doesn't appear in Q. Q doesn't appear in P. I actually think we have to do it. I think we have to enumerate all those choices. Okay, Q doesn't appear in R. Yeah, so we're going to end up with 6. So you can see this gets awkward very quickly. Oh no, I'm sorry. I mix up the absentos and the avalos. Okay, so P goes to Q. Q goes to R. And R goes to P. Okay. And then for the absento, P doesn't appear in Q. P doesn't appear in R. Q doesn't appear in P. Q doesn't appear in R. And then we say R doesn't appear in P, and R doesn't appear in Q. Okay. I have no idea how long this will take. Yeah, that actually wasn't that bad. All right, so wow. 1, 2, 3, 4, 5 quotes. List of quote lists of this thing. Okay, and then what does this one look like? List of quote lambda. List of quote list versus list of quote lambda versus the direct application of a lambda, which is like a let. List of quote list of quote quote list. List of quote. Okay. So at least the outer structure differs some. There's still a lot of shared structure, obviously. So here we have 5 quotes, here we have 4 quotes, here we have 3 quotes. Okay, so they're still very similar, but the outer structure is somewhat different. So, that does bring up a question. If we were going to, do quadrines, I don't know what the 4 would be. Quadrilateral quines, this would start getting out of hand very quickly with the absento constraints. So, that's something where I could imagine either a macro or a smarter constraint that's more general. Maybe that's interesting. And then this is sort of interesting question. Okay, so here's a good challenge. This is like kind of a interesting, playful challenge with the with this use of absento. We can get the outer structure to be different for these quines or twines or thrines, but they're still basically the same modulo the number of quotes afterwards. I think that's right. Yeah, they look basically the same afterwards. So is there a way to do maybe like a general version of this? So the thing about absento is it's lazy. It's a constraint. We're not enumerating anything or grounding anything by writing these absento constraints. So that's good, because as soon as you start getting into generating tests, you're in trouble. So, that's a nice feature of absento. But maybe we can imagine another type of constraint, a different constraint that would result in more interesting structures. Certainly, I can imagine a constraint that, would where we wouldn't explode in the number of constraints we'd have to write. So, anyway, that's my challenge to you, and I think I'll save this transcript, and then, we're thinking about it a little bit. So, let's see. What's a good way to do it? Let's go back to our notes here. Okay. So this is absento for more interesting quines and twines. Okay, one question. We have two questions here, I guess, at least. One question is, the quines and twines seem to differ structurally. That is, in a manner other than the number of quotes. Wrapped around an expression. Only at the outermost level. How might we get more interesting structural differences inside the expression? I don't know. I don't know. Okay, and then the other question is, as we move from twines to thrines to quadrines, the number of absento calls grows non-linearly. How to do better? How can we do better? There we go. I mean, so we could write a macro or a function or something like that, but you still have this problem of the blow up. It'd be better, ideally, if you really wanted to push that, of having a constraint that's more general and is smarter. So that reminds me a little bit of disequality constraints versus a constraint called all different, where you have a list of values that you want to say that all those values are distinct. So otherwise you have to do all these pairwise disequalities, which grows quadratically. Okay, well, actually that was surprisingly fun. That was 20 minutes. Okay, I thought I was just going to write some sentences, but we actually did some playing around here. So let me save this transcript, by the way. Whoa. Whoops. Where's this thing? Let's look. Yeah. Oh. Okay. Let's do it this way. Ah. There we go. Yeah. Excellent. Okay, well, that was fun. Actually did a little programming. Yeah. All right, well, that's a challenge. So think about it. Talk to you soon. Bye-bye.